Good morning, or midnight in my time, so you'll excuse me if I fall asleep and start to snore. There's absolutely no pressure here on me because I'm supposed to inspire and make you think. Yeah, thanks for that. I would like to probably describe myself as a disillusioned expert because what I do is I work in security, and everybody disillusions me every day. So my name is Barry Dorrans. I am the Microsoft Security Czar, at least that's what my manager calls me, for ASP.NET and everything that goes around ASP.NET. Which means that I bug absolutely everybody in Building 44 and beyond about security. Everything they do, I stick my grubby little hands in and try and make myself useful and provide helpful advice without annoying them so much that they don't want to talk to me, which is more difficult than you would think. I also get to swear a lot, and when things go wrong, when researchers find vulnerabilities, when the emails come in, I'm the person that gets those emails, I'm the person that has the initial sinking feeling in the stomach, and I'm the person that spends every Christmas panicking because there is a European conference that is on the 23rd of December. And for 2 out of the last 3 years, people have dropped zero-day vulnerabilities at that conference. If you want to follow me on Twitter, I am at Blowdart. It's not a very technical Twitter account, I have to admit. It mainly involves me ranting a lot or commenting on having herring for breakfast. But every now and again, there will be something security-related. Just don't expect it to be security all the time. So today I'm going to go through 3 MSRC bulletins. MSRC is the Microsoft Security Research Center. They're the people that you reach if you email secure@microsoft.com. They're the people that get the bulletins first, look through them, and then pass them down to me. And then I'm going to go through a few things that we've caught over the last few years in the framework and within bits of Azure before they got deployed, not after. Which proves I can actually do my job sometimes, including Unicode and how it's horrible and everybody should just speak English and stop putting accents above weird random letters like A's and E's. I'm going to talk about how people can misuse encryption. I'm going to talk about zip files and runaway processes, naive cert comparisons, and, believe it or not, still XSS. I'm not going to go through the OWASP top 10 today. I'm sure you've all heard that, and I'm sure we're all sick of it. It's unfortunate that people still make the mistakes on the OWASP top 10 that are listed. This is part of a learning process, and unfortunately, a lot of universities don't teach security to developers. So security is an ongoing learning process. Part of the secure development lifecycle is taking the things that we learn every day and putting them into processes and checklists. I know checklists are supposed to be for beginners, but when it comes to security, I have an enormous list of checklists that I make everyone go through. Because if you're not thinking about security every day, checklists are handy. But the things that you'll see aren't covered on the checklists. They're weird edge cases. They're things that we have discovered, or worse, other people have discovered, that we eventually incorporate and put into our SDL lifecycle, and we eventually come up with enormous checklists every year of things that we have discovered, and hopefully we'll catch them before we go forward. So, 3 tales of MSRC cases. These are my nightmare scenarios. These are things that researchers have found in released code, security bugs that people can exploit to do horrible, horrible things. Now, there's going to be nothing as exciting as Heartbleed or Shell Shock. This is going to be boring compared to those two, because we weren't vulnerable to either of those. That's not to say we didn't start looking into them. As soon as things come out which we're not vulnerable to, we still start plowing through our code base just to make sure. So Heartbleed was an absolute joy for that sort of thing. We had people going through all of our SSL code. Shell shock, yes, we actually started testing IIS because you can run Bash on Windows with Cygwin. You can run Apache on Windows with Cygwin, and we have to check everything. If it's a new approach, even if it's not on our platform, we start plowing through it and we start worrying that we might have done something like the vulnerabilities that have been discovered. So the Microsoft bulletin process is long. I'm sure some of you will shake your heads about how long it takes us to develop patches. It's not an easy process. I'm not going to apologize for how long it takes us to develop patches. The vulnerability gets reported to us. MSRC open a case, and then they check the vulnerability. They try to reproduce it before handing it down to us. If the reproduction is successful, then it gets handed to me. I start to panic. I drink an awful lot of coffee. I have a bottle of whiskey that sits on my desk that gets refilled every now and again. If it's a really serious issue, MSRC have their own little room. And this room is not on any of the building maps. It's very hard to find, which is great when you can't remember where it is. And actually, at the back of that room, in certain 24 hours, no one's going home scenarios, there is a bar. There is a stocked bar in the MSRC situation room. There's also a popcorn machine for some reason. So when I get the vulnerabilities that come down, I then spend a day to 2 days trying to reproduce it on every single platform that we support. And that is a long process. Then I'll hand it over to people who are much cleverer than I am to develop the fix. Or preferably, I'll hand it over to the person that made the mistake in the first place, because then they get to learn about it. Now, we're very good about that, actually. No one has ever tried to avoid taking responsibility for their own buggy code. People step up, people volunteer that, yes, it's their code base that has the mistake in it, and they're responsible for that fix. We fix it, the ASP.NET team, will fix it on the latest version. And then we hand it off to another team to do the really hard work of taking it down level to .NET 3.5 or 3 or even 2. Then we test the fix. The fix, again, is tested across every single operating system that we support. Our test matrix is huge. There are rather a lot of machines developing, or rather a lot of machines that we test upon for all the various different combinations. We then write the bulletin, which mostly is a matter of cutting and pasting from previous bulletins, although last year we had our first MSRC case where the software was delivered across NuGet, which confused the heck out of MSRC because they're like, what do you mean it's not on the Microsoft Download Center? What do you mean it's not going to come across from Windows Update? So they've had a little bit of a learning process. And going forward, NuGet is going to be our distribution model for ASP.NET vNext. So when ASP.NET vNext comes out, our general advice will be we want developers to pull down the latest binary, compile it, and deploy, because deployments are all self-contained. For those of you that are adminning large networks, there still will be Windows Update patches. So you don't have to wait for developers to patch your machines, but we'd rather developers take responsibility for their applications. And because everything's self-contained, we don't have to worry about backwards compatibility anymore. If you patch one website on your network, it's not going to touch any of the other websites on that same server, which makes us very, very happy. The fix will then get internationalized. We'll have it in lots of strange languages with lots of strange accents. The MSRC bulletins have to be produced in lots of languages. We'll then deploy the fix internally. Azure gets fixes first, because we can do a lot of A/B testing that way. We'll then distribute it to a select set of companies that do testing on their pieces of software. And then finally, the bulletin and the fixes are released on Patch Tuesday. Last month, you may have seen that we pushed out a fix for ViewState. You used to be able to disable ViewState Mac, and I will demonstrate why that is a really bad idea as I go along. This was the first patch that I know of for ASP.NET where we deliberately broke backwards compatibility to keep you safe. That's a new thing that we've done, and it's something that I am horrendously proud of. So I'm going to go through 3 security bulletins. The first 2 were Christmas security bulletins, which was absolutely wonderful when they happened. And then the last one is a SharePoint bulletin, which, whilst not directly associated with ASP.NET, was a ViewState Mac problem, so we were vaguely responsible for it, and we've patched that problem within the framework itself. I'm going to show you some deliberately bad code just to illustrate how these things happen and how they're exploited. I'm not going to show you any destructive code, and some of the code samples that I will show will not be available for download because they're doing things that we're still a bit concerned about. We've patched it, but of course not everyone takes patches. I would encourage everyone to take the patches that we put out. So first up, we have, from 2011, a HashDOS attack. This was a denial of service that anyone could send to an ASP.NET site just by sending a post request. It was not fun. It was deep in our architecture, deep in the way that string works. And what happens when you send a form post is we take the form post and we use the form fields as keys for a dictionary. And the way that we produce the keys for the dictionary is we call string.toHashCode. Now, we've never promised that string.toHashCode was going to stay the same. But the way we coded it, it did stay the same. It was predictable. And it was this very predictability that caused the problems. Now, we fixed it by switching the hashcode function to one that is unpredictable, that was written by a bunch of cryptographers in-house. We have a group of people called the Crypto Board at Microsoft, who are the scariest people that I have ever had to present in front of. Anytime we try and reinvent cryptography, it has to be signed off by a bunch of PhDs who just sit there and think about cryptography functions for fun. I mean, these are nice public cryptography functions that have undergone serious testing, and these people consider it fun. So, I'll explain how HashDOS works. I'll explain it by cats, because I found the cat explanation on the internet, and I absolutely adored it. I will have, when the slide deck is distributed, there are links at the bottom of some of these slides, so you don't particularly have to remember what I'm talking about. Hopefully you will, but you can, of course, go back and look over everything again. If you're running a cattery, somewhere that takes cats in and gives them a little cat holiday. I really should do this about dogs because I'm a dog person. I have a black lab, but the example on the internet was cats, and cats are evil, and security vulnerabilities are evil, so it fits nicely. Say you're the receptionist at this cattery, and you have to have some way of putting cats in places that you can bring them out again. So you decide what will happen is when you take a cat in, you're going to take the first letter of the cat's name, and you're going to put it in the room that matches that first letter. So if the cat's name begins with A, it's going to go into room A, and the cat's name begins with B, it's going to go into room B, and so on. And then when someone comes to get the cat, they tell you its name, you go into room A, and you lift all the cats up, and you look at the label on the cat. Not a label, that would be mean, the fur would come off. You look at the name tag on the collar until you find the one you want, and you take it back out again. So the more cats that are in a room, the longer it's going to take you to pull things back out again. And so the owner of a rival cattery decides to get a bunch of cats and name them all Alfred. So this guy turns up with 300 cats that are all named Alfred, and according to your system, they must all go into room A. So you put them all into room A. Room A gets very crowded, and cats being cats, they start to fight, they start to scratch each other, and they start to scratch the handlers, which is not what anyone wants. And then when they come to pick up Alfred, you have to go back in, and there's 300 cats, and you have to pick up each one, and it's like, this one's Alfred. You take it back out, it's like, no, that's not my Alfred, it must be another one. And so you go back again, and so on and so forth, and the amount of time to find the right cat exponentially grows. And that's your denial of service attack. By posting a specially crafted form field, the attacker, the guy that discovered this and wrote it, and it wasn't just limited to ASP.NET, I should say this now, PHP had the same, well, PHP always has problems. PHP had the same problem, Java had the same problem, Ruby had the same problem, Python, all of it. The original example was on Perl, and then someone decided to cause me a headache and ported it to .NET. So it was originally presented at the 28th Chaos Communication Congress, which is that Christmas conference that we all sit and watch and worry about. So in conferences like that, MSRC sends people to the conferences, and we're open about it. Everyone knows that we're there. We have our badges on. And they sit at the back of the talks that we think are going to be the most worrying, and they're there on IM and on Link, and a bunch of us are sitting on a conference call just waiting for it to all go wrong. So yes, this was presented at Christmas, and we had a little bit of a panic because it would be quite easy to bring an ASP.NET site down if you knew what you were doing. So we fixed it by messing with the way hash codes work. We applied the fix to dictionary because that's pretty much what everyone uses. And if you allow user input into your hash-based collection and you take user input as the key, then you may well be vulnerable. If your key is a string, we have fixed this for you. If your key is something generated from user input that is not a string, and you have not overridden get hash code, then you may have problems. So I'm going to do a demo for this. Frankly, the demos, they're not pretty, because these days I'm not much of a developer, unfortunately. I just sit and try and stop the ASP.NET people doing things that will make people unhappy. So some of my demos are straightforward command line, just to prove that it's not necessarily ASP.NET related, and I do vaguely know what I'm doing. So here I have a straightforward dictionary, good dictionary. Oh dear. What on earth happened there? All right, there we go. Oh, look, it extended. Let's stop that. This is where you see that I can't spell or type underneath pressure. This was duplicating before. I was vaguely prepared. There we go. Bye-bye, Metro. Oh, sorry, it's not called that anymore, is it? All right. So, we have a good dictionary, and into the good dictionary, I'm going to shove a bunch of items. How many zeros do we have here? I'm going to shove 1 million items that aren't particularly clever. They're just I'm going to use the loop counter as my key, and I'm going to put in a value. And we're going to time it, and then what drops out the bottom is, well, a reasonable time. And then I've written dumb string. And dumb string is basically going to override the hash code and return the same thing every single time. This is not what string normally does. String will do the equivalent of a SHA or an MD5 over the string contents. It's not SHA and it's not MD5. I should underscore this. it's been changed to something that's an awful lot more clever. And I'm going to start trying to put in 1/10 of the number of good strings that I've put in. So if I hit start, and oh, look at that, it's lost its nice settings. So we've already done 1 million from good string, and that's taken its time, and it took 484 milliseconds. And the bad one, which is doing 1/10 of what good string has done, is still going. So you can see that there is a problem here. And this will probably take, on my little Surface, about 5 minutes to run. So I'm not going to let it run. I'm going to cancel it, because otherwise the Surface starts to overheat, the fan starts up, and everything grinds to a halt. So it was this sort of attack on pre-computed hashes, and it switched itself back to duplicating the screen. Thank you, PowerPoint. So, like I said, we fixed this. We've changed the way hash codes work. We've changed the way dictionary works as well. So even in previous versions of .NET where hash code is still standard, we are prefixing the hash code for dictionaries with a random value that is set at the time your application starts. So that random value is going to be different from website to website. So it's not attackable anymore because that random value is not discoverable. Well, it's not attackable anymore until someone figures out a way to discover it, which is always possible. So you don't allow user input as a key into a dictionary or anything else that produces a hash function. You use something like SHA-1 HMAC because that takes a key in, which could be a random value, and it uses that as part of the calculation of your hash code. So we keep seeing people do this. So every time I see a dictionary where it's not a string as the key, I usually spend about a day and a half going over exactly how the hash code for that object is generated. I'm sure some of you will have dictionaries that use complex objects as their keys. You need to go away and look at your get hash code for this and introduce some sort of randomization at app startup for those hash codes in order to make yourself invulnerable to this sort of attack. Does this make sense? Does anyone have any questions? Now, last time I spoke in Scandinavia, I realized it's very hard to get you guys to ask questions. I would love you to ask questions, because if you ask questions that I can answer, my manager will see me being smart on stage, and next year I can angle for a pay rise. So, pay rise, simple, easy questions that I can answer, please, would be great, along with the green things at the end. Okay. I will remind you I've traveled 36 hours to be here because my original flight was canceled, so pity is also a good reason to vote green. Hello. The question is, why was it applied to dictionary? Dictionary is not owned by the ASP.NET team. Dictionary is owned by the core.NET team, which made me quite happy because I didn't have to come up with a fix. But then we had to implement the fix because the vulnerability came from ASP.NET. They gave us the patch. We tested it to make sure it wouldn't break ASP.NET because backwards compatibility is a huge thing at Microsoft. There are a bunch of changes we would love to make things more secure, but backwards compatibility is huge. We cannot, unfortunately, go around breaking things from version to version, unlike certain other languages and frameworks that are named after jewels do on a regular revision basis. Unfortunately, I'm not allowed to do that. So the fix was coded by the first fix for this was coded by us, and then it was fixed further down in the framework so it would cope with everybody. Now, for desktop apps, generally, we're not so worried about denial of service on desktop apps because you're denying service to yourself. You're crashing your own desktop. That's a less scary scenario than someone bringing down an entire website. So we we put a Band-Aid around it, and then we got the .NET people to fix it very, very quickly, and then we pushed this out as quickly as we could. Does that answer your question? Oh, why didn't we apply it in ASP.NET? Because it was a vulnerability all the way down. And so whilst I'm not concerned about desktop apps as much, the desktop team were. So if we can fix things at a lower level and protect more users, we're always going to do that, which is sometimes why it takes us a little bit longer to fix things than you think it would. Does that answer your question? Thank you. Oh, okay. Did this cause performance regressions? That's another thing that we don't particularly like to do. The quick answer is yes, but it was minimal. It causes a little bit on generating the hash code, but not as much as you would think, and we considered the performance regression acceptable in the name of security. Security is a tough balancing act, to be honest, on how we do things, whether it's speed versus security. As we develop ASP.NEXT, it's a constant discussion that I have with that team who are very performance aware, and sometimes I have to get them to slow down. Hashing passwords is a great example of this. A lot of people believe that the default number of hash iterations that we do in ASP.NET Identity is too small. And that may well be true. However, if we increase it, and we increase it to some of the numbers that people have been asking for, it would take a minute to generate a hash code for a password that a user has entered before we can compare it. And so now we've gone from taking a couple of thousand requests a second, and we've taken that down to 200 and even 50 a second. And that's a performance regression we're not willing to take. So I have to be pragmatic about things. Now, the way to fix that is we end up trying to speed up the hash code algorithm. And if we can get better performance out of the hash code algorithm, then we can increase the iteration count without bad side effects from what we have before. Does that answer your question? Okay. So yes, I would agree that performance regressions are okay if in order to make a security patch. Unfortunately, I have a bunch of other people who argue that we cannot regress performance because as we go forward, we should always be faster in the things that we do. And that's what customers tend to expect. Security is an incredibly hard sell. People expect everything to be secure without understanding some of the drawbacks of being secure and some of the compromises that you have to make. So it is a balancing act, and it is a discussion that I have on a weekly basis around things. It's a case of, this is going to be an awful lot more secure, but it takes 10 times to run. That's probably not acceptable. Therefore, well, okay, how about if it takes 5 times longer to run, and it's more secure than we have now. And so that's probably the compromise that we end up coming to. Otherwise, I would have password hashing algorithms that take 5 minutes. I'd be happy with that, but I don't think any of your users logging into a website would be happy that it takes 5 minutes from when you hit login to actually get into the next screen. It's a horrible compromise, and I have to be pragmatic about these things. Okay? Thank you. So, the next one. The padding oracle attack. this wasn't Christmas, I think. This was September. And then by the time it got to Christmas, we could do an entire fix that fixed it properly. So padding oracles have got nothing to do with the database. It is an information disclosure via a cryptographic attack. So what we had was an endpoint, a piece of code that was in every ASP.NET website that would return a different value depending on whether an encrypted string was valid or an encrypted string was invalid. That's all it was. It was sort of a true or false response. It was an error response, and you could tell. And what a padding oracle attack does is you just send this thing random strings, and you will be able to tell if they're padded correctly or not. And the way that block encryption works is it takes initialization vector, which is supposed to be a cryptographically secure block of random numbers, and then you take the first block of text and it's hashed against the previous block. And it loops around like that, and it moves forward. Now, what the attacker did was he took an initialization vector that he knew and attached it to a string, and would get this true or false back on the based on what he had inputted. And then he would tweak 1 byte in the last character and keep going until he got a true value. And he'd go, okay, I now know what the last character of the block is that I want to decrypt. And that's actually quite quick. And so you keep moving backwards through the block, because now you've got the last one, so you recraft your initialization vector, taking that into account, and you move backwards and you loop through 256 values, and wait until you get the true, and you skip backwards. And then suddenly you have an unencrypted block of text. So a padding oracle attack allows you to generally decrypt a string. Now, what they also did was the attack extended this, and they found a way to encrypt a string after they figured out a decrypt. And that would enable you to use scriptresource.axd, which used to allow you to serve up any file in a web application, which was admittedly very silly. Any file in a web application includes web.config. Web.config has your machine key in it, which is what we use as the encryption key for things like forms authentication tickets. So once you have that encryption key, you can now create valid forms authentication tickets for any user in a system. And at that point, all your security is useless, because I can now craft a forms authentication ticket that says, "Hi, I'm your administrator." So this one was a little bit serious. So we fixed this, thank goodness. The problem we had was there was a couple of methods on the machine key class called, that allowed you to protect and unprotect data using machine keys. And they gave developers too many options. You could choose to sign data, but leave it in plain text. You could choose to encrypt and sign data, or you could choose to just encrypt. And it's that last one that's horribly dangerous. Because if we had a signature and a valid signature that we could test, we would have rejected this padding oracle attack because the signature wasn't valid, because you needed the encryption key to generate a valid signature. So that's what we did. We took away the option to generate just encrypted data, and we plowed through all of ASP.NET to make sure those options were never called. They still exist because backwards compatibility, unfortunately. They will be going away in ASP.NET vNext. Because in ASP.NET vNext, because we are stripping out pretty much everything and writing it from scratch, I can finally break as much back compatibility as I want with a good security reason. So the bad methods are now currently marked as deprecated, so if you try and call against them, you'll get a warning from FXCOP. And I encourage everyone to turn on FXCOP. There are a bunch of security rules that are there that will be helpful. I know how annoying FXCOP can be. Trust me, I've sat down with the FXCOP team, and we have a bunch of internal security rules that were very noisy and don't provide an awful lot of value, and eventually we've killed about half of them. So this is just the explanation that I've gone through. It's got lists to the original presentations. And then Ty and Giuliano were the people that made us unhappy and took it forward and discovered how to encrypt using a padding oracle attack. In the slide notes, there is a link to a demonstration of how this works. The math is really complicated. I tried to write one. I completely failed because the math was just too hard. Their demonstration is, I believe, in Ruby. They're much cleverer than I am, but even the notes that go around it are discussing about how they're crafting each of the IVs, and you can see them do it step by step, so you can see how these things work. So, if you've written something like this yourself, basically you don't expose anything that says true or false based on whether something is solid or not. And you always add your authenticated signature to the encrypted data, and then, of course, you validate it when it comes in. Because adding a signature isn't much good unless you check it. And then, finally, the one case I want to look at is a SharePoint view state remote code execution. I hate remote code executions. Remote code executions are the let's drop everything that we're doing and go into a room and figure out how to stop this and no one goes home scenario. The SharePoint vulnerability was remote code execution via serialization. It was via view state, which is a serialized state of, well, lots of things, and I'll demonstrate it in a little bit. It was fixed by turning view state Mac back on. I have no idea why SharePoint turned it off, if I'm honest. We asked. I don't think we ever got an acceptable reason. Unfortunately, we used to recommend that people turn view state Mac off because calculating view state Macs took some CPU. We don't recommend that anymore. People also turned it off because of web farms, and it was too hard to set machine keys in web.config, apparently. We don't recommend that scenario either. This is the patch that came out last month that breaks backwards compatibility. We have removed that option. We worked very, very hard to make sure that it wouldn't break the vast majority of people. We haven't actually had any complaints that it broke anyone, including some people that we know who have view state Mac turned off. We did a little bit of a scan of some of our partners and some of our own internal sites to see if anybody had done it. And we discovered a few people, and there were a few emails sent to various teams going, you need to fix this right now, and can you tell us the scenario that you were trying to do that meant that you had to turn it off? And we tried to cope with that very hard when we sent the patch out. So this is discovered by Alexander Herzog. He presented it at Area 41 in 2013. He demonstrated remote code execution if a machine key is known or if view state Mac is turned off, because it's one and the same thing. Yeah, if view state Mac is turned off, you're not signing. If the machine key is known, you're signing, but somebody knows what to sign with. And he spent a lot of time actually going through third-party applications that we deliver via Azure, so the likes of .NET Nuke and that sort of thing, and looked for fixed machine keys that were never changed on install, and then sent us an enormous list and came to visit us and went, here are the people that you need to contact and tell them to change their practices. And we spent a month trying to get that fixed, and we pulled things from the Azure gallery until it was fixed, and then we figured out who'd installed it, and we sent out warning emails and all the rest of it. It was built on a remoting exploit. Remoting is what came before WCF and now belongs to the WCF team. And that was discovered by James Forshaw, who now works for Google, which is a bit of a concern for me. But I did buy him breakfast at Black Hat, so hopefully he figures he owes me one. And he'll be watching this recording, so James, you owe me one. And his remoting exploit used a .NET Framework class to delete files, which is what I'm going to demonstrate. View state has a problem in that it's implicitly trusted. So objects that get embedded in view state get deserialized, and as part of deserialization, certain objects will execute code. And the class that James discovered and made us very unhappy with is the temp file collection class. This class is serializable. Not all classes are serializable by default. And it's used to generate a bunch of temp files. When the class is garbage collected, it deletes all those temp files. The temp file path collection is a property that is also serialized. So you could create one of these with web.config as part of its temp file collection, and when it's deserialized and the object is constructed, web.config gets added to the set of temporary files. And when the object is garbage collected, which happens every few minutes in ASP.NET, your web.config would get deleted. If you have been using web.config in, for example, an administrator subdirectory, which a lot of people do to stop non-authenticated users coming in, that protection would suddenly vanish. So you could do this without bringing a website down, so it doesn't look like it's broken. But if you go to the /administration subsite and the web.config's not there, you suddenly have access to it. So I've got a little demonstration again, which is the command line. Thank you, Windows. Sometimes Windows is too clever for its own good. Yay, okay. So, I'm not going to close this dialogue now. I'm just going to leave it open. Yes, I want to keep these changes, and I want to keep them when PowerPoint starts up again. Thank you. So, here I'm going to create an instance of temp file collection. I'm going to add web.config to the temp file collection. I'm going to serialize the object. So this is just straightforward binary formatter serialization. And then I'm going to force a garbage collection so there's no cheating. Then I'm going to write out web.config. I'm just going to put hello world in it. And then eventually what will happen is I will just read in via this fake read view state. I'm going to read in the serialized object. Then I'm going to call gc collect to speed things up so it runs the garbage collector over the object. And lo and behold, we will see files vanish. So no cheating, straightforward binary formatter, nothing particularly exciting. And we'll see things that get created here. So, in my Explorer window, you will see I have web.config. And I've written out my serialized view state in inverted commas. View state is a little bit more complicated than this, but it's much the same principle. So I'm going to hit enter. And if you notice, there's no web.config anymore, which really didn't make us happy when this got public. Now, these things that I'm showing, now Alexander was very nice. He came to talk to us first. I like it when people email us first and come to talk to us because we can fix it before they present. And we try and work with people if they're going to present at a conference so we can get the fix first, which sometimes means it's a slightly smaller time scale for writing fixes than I would like, unfortunately. But I would far rather that people let us know than drop O days at conferences and then I have to stop eating Christmas dinner. It doesn't help that most of my colleagues have kids and families, so it's usually me that's on call because it's just me, the girlfriend, and the dog. So it's less hassle for me to be the person that gets, disturbed. Although some people will say I'm disturbed in a whole bunch of other levels, but that's an entirely different discussion. Okay, so let's go back to Windows thinking, you just didn't change. Duplicate shite. Ooh. There's an option up here that says duplicates. Yes! Okay. So, the way we fixed this was we have disabled ViewState Mac. You can't turn it off now. It's always going to be signed. So, if you try and fake a ViewState, if you try and fake serialized data, the signature that is appended to it is not going to match, and so we're not going to deserialize it. So, you'd have to know what the encryption key is to deserialize, which is another good reason to, if you're publishing on GitHub and you're writing an application, don't set static machine keys and publish them to GitHub. Every now and again, I will run a search over GitHub for things like machine keys and Azure publish settings, and then we'll figure out who owns it, and we'll send them a nice email saying you really shouldn't have done this, and we'd like you to rotate all your keys. So those are the 3 vulnerabilities that I wanted to go through. Now I'm going to talk about some things that we've discovered before they became vulnerabilities. I'm sure there are other things we haven't discovered yet. No one is perfect. You're always going to make security mistakes, unfortunately. The key is how quickly you respond and how you treat the people that report things to you. One of the worst things that I've seen companies do is if a researcher comes and reports to them is to sue to try and keep people quiet. There is a mailing list called Full Disclosure, which tends to be full of people dropping 0 days because they're with companies that will sue, and there's no point trying to be nice to those companies. If you are publishing applications, if you are publishing websites, I would encourage you to look for coordinated disclosure policies. Talk to your legal people. I spend, an hour, 2 hours a week, emailing backwards and forwards with lawyers, which is probably the worst part of my job, trying to figure out ways to whether things need to have legal involved or not. If you have a clear, responsible disclosure policy where you're upfront about what's going to happen and how researchers are going to be treated, they tend to want to work with you rather than to work against you. Although, unfortunately, working for Microsoft, some people just want to work against you anyway because it's fun and we're huge and there's a certain amount of kudos in getting us upset and spoiling my Christmas dinner. So, this is from last week. This is quite common. I saw this in a Razor View. Someone had posted to a list asking why this didn't work, which is great. I like questions about why this didn't work. The answer he got wasn't what he expected. The answer he got was, we don't care why it doesn't work. We do care that you've now got a security vulnerability. So does anyone see what's wrong? No? Okay. This seems to be doing the right thing. This seems to be taking user input and running HTML and code over it, which is what we do. I mean, when we're working in Razor, that little @ sign will HTML encode anything that you put after it. But this is inside JavaScript. JavaScript encoding is entirely different to HTML encoding. So with this little piece of code, because it's inside JavaScript, because it's inside an event, it's very easy to craft title to introduce XSS. And encoding is hard. Getting the right encoding is very hard. We encode everything as HTML attribute encoding within Razor because it's too hard to figure out whether you're inside an attribute or whether you're inside just straightforward HTML. HTML attribute encoding is a few extra characters that end up being their ampersand value, so we're not particularly worried about, that little extra bit of size. So for this sort of thing, the recommendation is you just set a div. You put the title in here, and because the div is HTML encoded, it's encoded in the right way. And then you pull the contents out in JavaScript, you set it in the attribute, and we're all good to go. So it's subtle because it looks like it's doing the right thing, but when you think about where you're encoding and the context in which you're encoding, it becomes incredibly hard. It becomes really hard when you start trying to chain things. You could have perhaps done, we could have encoded to JavaScript and then wrapped it and encoded it in HTML encode. If you get the order wrong, you're just as vulnerable. So we much prefer that you run an encoder once and then use JavaScript jiggery-pokery to pull it out. Another one I've seen about 6 months ago was abusing REST and REST URLs. So we have a user admin page that an admin is trying to hit, for example, and it takes a username that's underneath user's control, because when users register, they can register with whatever username you want. So the admin might have a REST endpoint that has delete, and it's passing in the username as part of the URL parameter, and you construct the URL by that. And this is an unhappy thing, because people do this. And browsers will quite happily drop that full stop and a slash. So it's replacing the username that you think it is with admin, and you end up deleting yourself. So for this sort of thing, for user input for usernames, we try and constrain people to 0 to 9 and A to Z and a couple of other underscores and things like that. To fix that sort of thing, we generally recommend that you use query strings rather than building up URLs. I know people like URLs because it feels wonderfully restful, but in certain cases, security overcomes the prettiness of your API. We have the Turkish I problem. I am aware that Swedish has a really interesting set of accents over characters that I've not seen before. Turkish is even better. Anyone like to take a guess at what this is gonna output? Let's face it, it's one of two values, so someone's gonna get it right. Hello, sir. I'm sorry, Windows Forms. Oh. Yes. Well done. So I will show the demonstration to prove that the man on the end of that aisle is in fact correct. I don't have any swag, which now makes me feel really guilty. All right, so let's look at the code first. Did it come? It did. PowerPoint didn't reset. That's wonderful. So I'm doing a compare. Nice and straightforward. And this is what we think. Can we see this at the back, or do I need to increase the font size? You're very far back. Yes, okay. Someone says, yes, I need to increase the font size. I had these all configured as well, and it's reset itself. That's lovely. How's that, people at the back? Yay! So the first comparison is true. Exactly the same code is false, because what I've done is I've switched to Turkish. And the man is entirely correct. The way Turkish runs is upsetting, to say the least, because of the way Turkish eyes work. And we've seen this before. Phil Hack, when he was with Microsoft, blogged about this 3-4 years ago, and we still see it. And there's an FX cop rule for this as well. People make security decisions based on string comparisons. And as soon as you start to internationalize, and it's nice actually being with an audience that should care about internationalization, in America, it's hard to make them think about languages that aren't English, that aren't American English even. I mean, trying to get them to spell center correctly is an ongoing battle for me. I documented a bunch of internal systems, and I did everything in English spelling, and even the code had English spelling, and our tester thought it would be very, very, very funny to log bugs that marked things as being spelled incorrectly, which I would then close as cannot reproduce. So, don't compare strings with double equals. Of course, anyone that's used to JavaScript isn't going to compare anything with any type of equals, because 1 equals, 2 equals, 3 equals, I just don't know. So we have string.compare, and it's important that we actually use the string comparison types to get this correctly, because they are culture aware, and having things that are aware of culture in America is also difficult at times. I'm going to get so much grief for this when I go back. So like I say, there's an FX cop rule for it. Turn it on. It will complain when you do string comparisons that are not culturally aware. Then we have, that's an example of one piece of Unicode madness. Then we have a great piece of Unicode madness. I got someone who logged a bug with the anti-XSS component. How many of you are familiar with that library? Ooh, more. That's mine. I wrote that. Well, I rewrote it eventually. And people said, oh, Unicode has this concept of full-width characters, which, it's very American. They've probably eaten too many pancakes. So we have, in the second bullet point, a skinny less than. In Unicode, we have a full width or a fat less than. It's actually 2 characters, 2 Unicode code points. And browsers will ignore this and do the right thing. So what we have here is we have script in wide characters. And on this, in the notes for this slide, there's a link to a website that will allow you to change normal characters into full width characters, which you can have fun with. Twitter is really quite hilarious with this. It doesn't strip them out. And you can use the changing direction character to actually start overwriting parts of the Twitter URI with your username. The fun part was if you put this wide character into a SQL varchar field, which isn't a Unicode field, so there's problem number 1, SQL decides to try and do the right thing. And rather than drop the character, it will replace it with a normal less than. And then that gets written out to an HTML page, and lo and behold, we have XSS, which is sad because XSS is still there in the OWASP top 10, and people don't think about it. So I got a bug report for anti-XSS that said, why isn't this being stripped? Why isn't it being fixed? And it's not an encoding problem. It's the fact that you've used a non-Unicode column to store Unicode characters. So again, something subtle, something based around Unicode and internationalization. And the fix is obviously use nvarchar. And this illustrates something else. You shouldn't trust things that are in your data store. Don't encode characters on the way in. Don't store encoding characters. You should encode data on the way out at the point of rendering. That enables you to change the encoding based on the context. So you can switch from HTML to XML to whatever the heck else is fancy, JSON or Bison or whatever is trendy this week. It's hard to keep up. A few more common cryptography mistakes. I've only got 5 minutes. I'm not going to make it through this. This will be fun. This one, a quote from a PM, quote from a project manager at Microsoft when I asked a question. Now, this is funny, but English wasn't their first language. They actually did mean to say encrypted. I did query it, though, much to the amusement of their team, who then spent the next week saying absolutely everything was base64 encrypted when they checked in code. I've seen this. Don't come to me saying you have a new encryption algorithm. I will laugh you out of the room. And then I will send you to the crypto board if you think that you're cleverer than I am or they am, and they will soon point out to you how incorrect your assumptions of encryption are. We've seen a lot of key and initialization vector reuse. When a document or a resource changes, you need to start rotating your keys. Don't keep using the same key for encrypting different bits of data, because there is a possibility of leaks when you can compare the encrypted blocks. Keys have purposes. If you use any of our data protection APIs, and if you play with vNext, you'll see this because everything demands a purpose now. That's a way of putting a string into a key derivation function. So something that is encrypted with one purpose will not be decrypted with another. So if you have view state as a purpose and forms authentication as a purpose, even if they use the same encryption key, the same master key, you can't decrypt a view state with the forms authentication encryptor and decryptor because the purposes are different. And we're going to make that easier for you in ASP.NET vNext. Levi Broderick, who does all the hard work with ASP.NET Security, he's the one that actually implements the vast majority of it. I just sort of like point him and say, can you make that more secure? And he goes away and does it. And then being a kind of product manager, I take all the glory for it because that's what I do. He has spent months trying to make this easier and trying to remove any possibility of failure from framework users' hands. We have combining strings. I've seen this a few times. So we have, when people want to hash or sign strings, they usually concatenate them all together. But there's no way to tell whether built-in plus securely is different from built insecurely, because when they're all combined together, they're exactly the same. So you put something like the length in, or an array offset, or something like that, so you can tell where one string ends and the next one begins during concatenation. I've seen certificate verification for hostname alone. Please don't do this. Because it's easy enough to craft a certificate with any hostname that you want. We have cert pinning. I'm not going to show the demo because it's very boring, but it's there so you can see the code behind it. We introduced this in Katana for the Twitter bits and pieces, and then Twitter changed their certificate without warning us and broke everything. Thank you, Twitter. So you take certain properties out of the certificate which aren't the subject name, and you compare based on those. Normally, it's the public key plus the algorithm, because when people renew certificates, you can keep the same public key. So when a certificate expires and gets replaced by another one, if the public key is still the same, cert pinning works. And this is what Twitter does, this is what Facebook does, this is the algorithms that Google use for all their cert pinnings on various other platforms other than Windows Phone. Because you can't do this in Windows Phone yet. The APIs just aren't there. Hash comparisons should be time consistent. I've seen people, when they're checking usernames and hashes of usernames and passwords, just do a straightforward equals. Not good enough. The amount of time it takes for a hash algorithm to fail should be exactly the same as it takes for one to succeed. Otherwise, you have an equivalent of a padding oracle attack, which we saw a few slides ago. We have mass assignments. MVC and Web API use binders. Binders take input and so on and so forth. So people reuse their models. People reuse their EF models during forum posts. And they just don't display certain properties in the field. But if I edit the HTML and put a value in with the key name of one of your properties and a value that I want, MVC model binding will pick that up, even though it's a hidden field and it wasn't in your original HTML, and shove it into your model. So you should either use view models, which I'm sure we're all used to by now, or you copy properties over manually. This is perhaps a bigger issue in Entity Framework because people are just expecting Entity Framework to do the right thing, and it does. It does exactly what it's told to do. Unfortunately, reusing the models is not the right thing for you to do. You actually have to put some work in and use view models and map between them all. You also have the option of doing bind include. That has some caveats where if you're overwriting an object and it ends up with a default value for, say, a Boolean, it's always going to reset to false if it wasn't part of your form. Path transversal. People will accept HTML uploads. HTML uploads include a file name. You can edit that file name before it goes up if you use something like tamper data or fiddler. If you put .. in that file name, HTML will not strip it out, or ASP.NET will not strip it out. It's not supposed to. It's up to the browser to sanitize the HTML. So don't trust file names that come out. Strip things, concatenate. We have system.io.path.getFilename, which will drop every path component out, and then you can combine. We have zip bombs. This is a larger problem than people would think. There are zip files. 42.zip is the funniest one. 42K that expands out to 4.3 gigabytes. So people will accept zip files, dump them on their hard drive, and then your virus scanner goes absolutely wild. Or you try and unzip them, which is great. So what we tend to do in that scenario is we have a different process for unzipping. We'll spawn off that process. We'll let it run for 5 seconds. If it hasn't finished, it gets killed and everything gets cleaned up. It's the only way around it. Or you find a zip library that allows you to limit the amount of path transversals it goes down before it errors. Either one of those is good. XML has the same problem. Billion laughs. This is on Wikipedia. You can create one of these, try uploading it to something and see what happens. Does pretty much the same thing. It expands out. It's really small and expands out and takes out a lot of memory. You turn that off with DTD by turning off DTD parsing. So I'll quickly finish up. We opt into protections. Because back compat is such a big issue, some things we don't switch over by default. So when you're compiling, when there's a new version of the .NET framework, retarget your projects, please. Change web.config to target the latest versions. You'll get the latest protections automatically. If you leave it at 4.5 instead of 4.5.1, some of the things that we fixed won't be turned on by default. String hashcode randomization isn't turned on by default. You need to turn it on in web.config unless you're on later versions of the framework when it is. Data protector. This is where we had our problems with our padding oracle attack. We're introduced in 4.5 machine key.protect and unprotect, which replace encode and decode, and this will now always sign your data. And as you can see, we have a purposes flag, which I talked about earlier with forms authentication and with view state and whatever else. So we're trying to help you do the right thing, and you'll find that encode and decode will go away in ASP.NET vNext, hopefully. If you are generating machine keys, I've seen a bunch of websites that generate machine keys for you. Don't do this. You don't know if someone's keeping a hold of that. They can work out where you're coming from. You never know. We've given you a PowerShell script. I tried to paste the PowerShell script into the slides. It's too big. So go to that website, which discusses view state and machine keys and a bunch of things about load balancing. Will hopefully help you if you ever run into that sort of problem. Stop using partial trust. I am going to demonstrate this because it's funny, even though I'm slightly running over. So I'll demo that. Please don't use request validation anymore. We don't consider it a security barrier. It will go away soon. The problem we have with request validation is it's too context specific. We don't know what's right for your fields and what's wrong. And what we have right now, you can get around reasonably easily. There's a URL there that has a talk, that has a transcription of a talk from Damien Edwards that talks about this sort of thing. So, partial trust. Here I have a website that is running in partial trust, hopefully. Do any of you still use trust levels? Do any of you know what partial trust was? So partial trust was a way for us to try and limit the permissions that a website could have on a hosting service. This is the demo you will not be getting source code to. So partial trust, it's a setting in web.config. Let's just prove this so I'm not cheating. Where are we? Partial trust. Oh, stop that. Trust level is medium. And it would stop you doing things like process.start or moving outside of the directory that your website is in. And where is it? There we go. So if I launch a shell, I get a security exception because it was trying to launch a command. So then I'm going to stop this. I'm going to switch to there. And then I uncomment out process.start. I go to our sneaky bit, which you don't get the source code to, and I'm not going to show. So I've just switched these two things over, launch a shell. Oh. So, this doesn't have to be command.exe. It really doesn't. This could wander all sorts of horrible places. So we consider trust levels irrevocably broken. You should be using the NT process isolation that we have in IIS. There's an entire knowledge base article around that will help you migrate if you were using them. So I have ran over, because I do every single time, and I'm half asleep. Do we have any questions? We've probably got like 2 or 3 minutes, and that's about it, I'm afraid. You can find me while I will be mainlining coffee outside. I may come along for beers later, but I've got to get up at 3 a.m. in the morning to fly back to Seattle, so yeah, it'll be 1 beer and that's it. Does anyone have any questions? No? Are we all asleep? Really? Did I scare at least some of you? I like to know that I've scared people who will go back and start reviewing their code. Yay! Scaring card, it's the green one on your way out. I'd like to thank you very much for inviting me and for letting me have pickled herring for breakfast, because I do enjoy that when I can get it. Thank you very much, everyone. Have a great day.